So last thing we're going to do for this unit, and then we're done. It was a very quick, short unit. We're going to do linear regression, and then the new piece is going to be correlation, which is no extra steps. Desmos calculates it for you. And what the correlation does is it tells you how close or how accurate your line of best fit is to your data values that you've plugged in. So if it's very far apart, we'll see what happens with the correlation. If it's very close, we'll see what happens with the correlation. So there's two examples, and we're just going to build correlation right into it. So for this first one of the jobs of the National Center for Education Statistics is to gather information about public high schools and their dropout rates. This includes anyone who leaves school without a high school diploma or an equivalent credential. The table shows the average percent of high school dropouts from the year 2002 through the year 2014. So our first job is to create a scatter plot of the high school dropout data. So we'll do that really quickly. Okay, so I created my scatter plot. Instead of listing like the years 2000 to 2003, I just made my x-axis years since 2010. So, or years since 2000, I should say. Years since 2000. So then this is 2001, 2002, 2003, 2004, 5, so on to 2014. And then I included my dropout rates, created my scatter plot. So now we're going to use the table and the graphing calculator, which is on Desmos, to create a linear regression line equation. So we'll pull up Desmos and we'll type in the information from the table. So remember, we hit the plus sign and then we hit table. And then I will do the same 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 to signify the years. 14, and then I'll type in my high school dropout rate. Okay, so now I have it on my scatter plot. I'll zoom over, zoom out a little so I can see it all. Looks pretty similar to what I have in my scatter plot picture. I think I did a pretty good job. So then scroll down to our next line and we'll type in our linear regression equation, which is again y1 squiggle mx1 plus b. And we have our m value, we have our b value. So I will plug those in. So we have y equals m, which is 0.03 x plus b, which is 3 point, we'll round to 6. So our next step is we want to interpret the slope and the y-intercept of the equation in terms of the problem situation. So we are going to say that for my slope, which is 0.03. Remember, rise over run, y over x. So the dropout rate is y. Dropout rate goes up because it's a positive number by 0.03% each year. And year was my x value. So it's always going to be my y value and then my x value at the end. So y value, x value, and then whatever your slope is just kind of goes in the middle. And then for my y-intercept, which was 3.6. And remember, this is just a prediction. So it is predicted that year 0, which in this case is year 2000, because that's where my graph started, was year 2000. So predicted that in year 2000, the dropout rate is 3.6%. What is the correlation coefficient, or your R value, rounded to the nearest hundredth? So this is the new piece, correlation coefficient. It's our R value. If I bring Desmos back up, hopefully it's still all there, and it is. My R value, I can't zoom in, but it says statistics, and it says R squared, and then it gives you this R value of R equals 0.1858. The closer this number is to 1, the better correlation coefficient you have. Okay, so again, the closer to 1 your correlation coefficient is, the better your line of best fit is. Kind of however you want to explain this. I said it's not the best line of fit. The R value is close to 0, which means that it's not very accurate. Now we're going to use our equation to calculate the estimated dropout rate for the year 2010. Is it the same as the dropout rate recorded in the table? If not, explain the difference. So we'll use this equation right here. I'm actually just going to copy and paste it into my question, and I'll replace this X with 10 because we want the year 2010. So X equals 10 in this situation. So 0.03, or Y equals 0.03 times 10 plus 3.6. And I'll bring out Desmos again. I'll go down to the next clean line. 0.03 times 10 plus 3.6. And we get a Y value, or a dropout rate, of 3.9%. So we're saying it's predicted, because this is the line of best fit, or the line of prediction. It's not actual fact. Predicted, the dropout rate will be 3.9% in 2010. Now let's take a look at what it actually was in 2010. And in 2010, the actual dropout rate was 3.0. Okay, so we are not very close. If not, explain the difference. Well, the difference could be because our correlation coefficient, that R value from the last problem, was saying that our line of best fit wasn't very accurate. So I'm going to say that our line of best fit wasn't very accurate. So our predicted value was a bit off. Okay, and then use your equation to calculate the predicted dropout rate for the year 2022. That's a tongue twister. So in 8 years from now. So not on our graph yet, but again, let's just paste that same equation in. This time X will equal 22 because it's 22 years since the year 2000. So we'll plug in 22. Y equals 0.03 times 22 plus 3.6. Desmos again, I'm just going to erase that 10, type in 22. And 4.26% dropout rate. Oops. In 2022. So that's a pretty high dropout rate compared to Some of those 3.0s, bit scary. All right. Let's do the second one, since correlation coefficient was something new for us. If you think that you've got this handled on your own, go ahead and try it on your own. Otherwise, stick around for the rest of the video. Mr. Lee is a math teacher at Pinkston High School and is preparing his students to take the SAT test. He collected data from 10 students who took the test last year and presented this information to the students in a table. The highest SAT score a student received was an 800. Analyze the data in the table. So first we're going to create our scatter plot just like we did before. So I'll quickly do that. We have our scatter plot created. Time spent studying in hours is on our x-axis, and the math SAT score is on our y-axis. This was a pretty tough one to graph. I definitely did not enjoy that, but we got it done. This one looks like a lot better trend, so maybe we'll see a better correlation coefficient. So I'll pull up Desmos. I'm going to clear everything out so that I have a fresh new table to create my linear regression. So plus sign table, and we'll just type in all the information that we see. Okay, so we've got all of our information into our table here. So we'll go down to line 2 and we'll type in our equation. Y1 squiggle mx 1 plus b. And we are given our slope and our y-intercept. So y equals 22.54x plus 344.19. Interpret the slope and the y-intercept in the context of the problem. So for our slope, which we said was 22.56, remember we're going to describe our y value first and then the x value. So the y value, math SAT score went up 22 points every hour you study. 4. Okay, so again, we have SAT score, hour you spent studying for, y value, x value, and the number is in the middle. And then for my y-intercept, which was 344, we'll just round to 344, we're saying that if you study for 0 hours, you will get a 344. Actually, let's round it. 344. Even though you really can't score 344, it's in increments of 10, so you'd either score between a 340 and a 350, but that's okay. Correlation coefficient, that R value, rounded to the nearest hundredth. So we look at Desmos again, and this time our R value is 0.95. Okay, very close to 1. So what does this value tell you? It is very close to 1. So we have a pretty accurate line of best fit. Our predicted values should closely match Okay, so what this strong correlation tells you, Since it's very close to 1, we have a pretty accurate line of best fit. Our predicted values should closely match our actual values. So we're going to use our equation that we found in part B. So let's copy and paste that. Copy, paste. We're going to use that equation to estimate the SAT score if someone studied for 14 hours, which we actually had someone who studied for 14 hours. So let's see how close we are to what was actually recorded in the table. So we'll plug in 14 for x. Y equals 22.54 times 14 plus 344.19. And 22.54 times 14 plus 344.19. And we're saying that 659.75, this is our predicted SAT if you study for 14 hours. Predicted SAT score if you study for 14 hours. Let's check out what it actually was. So the person who studied for 14 hours actually received a 700. Oh man, why were we so off? Let's see where our values are. Okay, I'm actually going to change my window so I can see those all of the points a little bit better. So I'll change my x-axis to be 0 hours studied to 30 hours studied. 30, not 300. And then my y-axis is the SAT scores. It looks like we had from a 300 to an 800. So I'll just type in 900. There we go. Okay. So at 14 hours, so 10 to 4, it looks like that point was pretty far off from our line of best fit. This was 14 hours. See where that 14 is hitting the dot? It was actually pretty far away from the line of best fit. So 14 was not a very accurate point in relationship to this problem. And that's why it's so different. But if we look at some of our other points, so for 12, pretty close to the line. So that's pretty accurate. 10 hours studied, very far away from the line, not very accurate. 9 hours studied, pretty accurate. 7 hours. Some of these points are pretty close to the line of best fit. And that's all we had. Okay, so last little part before we're done, use the equation. So we'll paste that right back in. To calculate the predicted SAT score if someone studied for 30 hours. Does this answer make sense? So we are going to plug in 30, 22.54 times 30 plus 344.19. So actually, let me just erase that 14. We'll plug in 30, and we have a 1,020, and I'm just going to round off to the nearest whole number. No, this number does not make sense because the highest math SAT score a person or a student can achieve is an 800. So eventually, you're just kind of going to cap off on a score. It's not saying that you can study forever and your score is just going to go unlimitedly high. Caps off at 800. So this person who studied for 30 hours, the highest that they could ever score is an 800.